Hello everyone and welcome back. I hope you're having a great day. It is time for another update, and today we will continue our work with the projectiles and get them going. But before we start, I gotta do my usual bit by asking for a like if you enjoyed this tutorial and also to subscribe so you don't miss the next episode. We got a lot of work for our projectiles and some of that will come in our next episode. But now, let's get into the episode. Let's just begin where we left off the last episode. So we start the game and take a look. We have the turret with a turret range, as well as soon as they get in range, they get damaged. But now we want to actually add the projectiles. And last episode we made a class projectile, and we also made some projectile constants in our constant class. And what we want to do now is whenever the tower sees the enemy, instead of just hurting the enemy, we want to shoot a projectile. So that's what we're going to start working on right now. And we begin by adding a new manager in our manager package called ProjectileManager. And this manager class will take care of all the logics and also the drawing of all the projectiles. So we need a constructor to begin with. And this manager will take in a playing, private, playing. And of course, import the class. This dot playing equals play. We will need a public void draw, graphics, G, import that class as well. We will need a update, public void update to begin with. We will need a private array list with projectile called Projectiles equals new array list. We need to import the list first and also projectile. We will need a private buffered image array of proj images. That's good enough. And this is where we store all the images for all the projectiles. And let's start by importing the images. So first we need a private void import images. And let's go to our sprite atlas and see where the coordinates are. So we have the projectiles on the second row, 7, 8, and 9. All right, can just place some temporary values here so we remember. X, 7, 8, 9, Y, 2, or Y1 actually. We need the atlas, buffered image atlas equals load, save, get sprite atlas, and then we make a quick loop here for int I equals 0, I is less than 3, I plus plus, and proj images I equals atlas dot get subimage, and we're gonna start on the 7 plus I, and we need to make that into a times 32. And Y will be 1, or 32 rather, and the sizes of them will be 32 by 32. And I think that's gonna turn out 0, 7, 8, 9. So yeah, that's gonna import the images. Now we can remove that, we don't need that anymore. But we need to call this method, import images. Oops, like so. And to make sure that we got all the images imported correctly, let's just make a draw function here and call if we can see them. So for buffered image, and we need the project images, g.draw image. I draw it in the center, so like 300, 300, null, and like so. And we need to create this manager in our playing here. So let's put them underneath our tower manager, private project manager, ProjectileManager. So we don't have to spell that every time. And project manager equals new manager, this. All right, and to our update method, we call ProjectileManager.update. And for our render, let's draw them here. Draw G. So if we run it now, we should see, we don't see anything because it's crashing right away. Why? Oh, we never created this one, of course. Equals new. Are you happy now? He's happy now. All right. They all clump together, but they are visible. So we got the images imported correctly, which is good. Then we can just remove this draw function. We just wanted to see if it worked, and it did. And in this manager, we will need a public method for adding or creating projectiles. So public void new projectile. And we will take in a tower T and an enemy E. Instead of saying XY start and XY end, we can just pass in the tower and the enemy, and it's starting from the tower and we're aiming for the enemy. So we're just going to import those two classes. And depending on the tower, we're going to have a different type of projectile. So we're just going to say int type equals get projectile type. And we pass in the tower. And we're going to create the method as well, but let's put it at the bottom. And we make a switch here, switch t.get tower type. And we add a case archer, case cannon, and case wizard, I think the last one was. We don't have those values, but let's import them. Import static helps, constants, towers, and let's take them all. If it's an archer, then we return arrow. If it's a cannon, we return a bomb. If it's a wizard, return chains, I think we called it. And we're gonna need those two, so let's copy that string, but instead of towers, we say projectiles dot and star. And now with the type figured out, we need some sort of direction for our projectile to go. But currently, we only have left, up, right, and down. But the enemies are not always going to be in any of those directions. They can also be slightly above, to the right, slightly to the left, and a little bit up as well. So we're gonna need to figure out some way of dealing with this. And the easiest way to explain how we're gonna solve this issue is with the image right here. So we're gonna have a tower and an enemy at some random positions, and we want to figure out how fast should a projectile go in the X direction and how fast should it go in the Y direction. And the way we're gonna figure this out is that we take the X distance as well as the Y distance to get the total distance in length. And with this total distance we're gonna get now, we can divide X distance with the total distance to get the percentage of the total distance for X. Then we get the X speed by multiplying speed, which in this case is 10, with the X percent. And then we have the X speed that will be updated every update. And to get the Y speed, we need a Y percent, and we get the Y percent by 1 minus the X percent. So now we have both the X speed and Y speed, and that is how we're going to update in every frame, or every update rather, the position of the projectile. So let's get this into the code as well. But we're gonna need a new variable in our projectile, or actually two variables. We will need a private float X speed and Y speed. And looking at the code, we should probably change how the public void move works. So instead of giving it 2 positions or 2 speeds, we will just remove these 2 and plus x speed and also y speed. But we need to get these 2 values, x speed and y speed, into our projectile. And we're going to add them in our constructor. So float x speed as well as float y speed. Float, not flout, like so. And we also need to save them. This dot x speed equals x speed. This dot y speed equals y speed. And now with those values added into our projectile, let's go back to our manager and figure them out. So we will need a float x speed and a float y speed. And first we will get the x distance. So int x dist equals math.abs t.getx minus e.getx. But we need to cast this into an integer. And then we need the int y dist equals math.abs t.getY minus e.getY. And now we need a total distance, which is int dot dist equals x dist equals y dist. And with the total distance, we now need float x percent, which is x dist divided by tot distance. And I'm just going to cast one of these into a float to make sure we actually get the correct type of division. And to get the float y per equals 1.0 float minus x per. And now we can get the speed by going x per times speed, which we get from helps dot constants dot projectiles get speed, and we use the type and we just copy that, and y speed will be y per times that speed. But we can actually remove a little bit here. We can remove y percent and only use the current speed minus x speed. So this way we get the same result, but we don't have to use x percent. But before we create a projectile, we need to think about positions. Right now, both the x speed and y speed are going to be positive, but they might actually need to be negative in order for them to go left or up. Right now, they can only go right and down. So we need to figure out a few things. If t.getx is larger than te.getx, what we're checking here is whether a tower has a higher value than the enemy in x position. If that's the case, then the projectile needs to go to the left. We're shooting towards the enemy. So x speed times -1, so we're flipping it to a negative, times equal -1 to a negative value. And then we need to do the same check for y position. So if t.getY is bigger than e.getY, then y speed times equal -1. And now with all the values figured out, we can actually add a new projectile by projectiles.add new projectile. So first is the position, which will be t.getx. And we're actually going to +16, so we start in the center of the tower, which is, it looks better. And then we get the y is t.getY +16 as well. And for x speed, I think it's next, yeah. And then y speed, we need ID, which we'll keep at 0 for now. And we also add a type, which is that one, like so. Actually, let's fix the ID right away. So instead of 0, we say projectile ID ++. So we create the value up here, private int projectile ID equals 0. So every time we create a new projectile, we give it the projectile ID +1. And to update our projectiles, we need to make a loop for projectile p projectiles p dot move, right? Yeah. And for our draw, we copy the same. And to get the image, we go g.drawImage, that one. And to get the correct image, we can just projectile images and get the p.get projectile type, p.get pos x for position, and p.get pos y for y position, and null. And I think x and y is going to be float, so we cast them over to integers to get the error message away, and it's gone. And if everything is working now, all we have to do is whenever the tower sees an enemy, he creates a new projectile. And what we say here is playing dot shoot enemy, T and E, and we add that method in our playing method, or in our playing class ProjectileManager dot new projectile T and E, like so. If everything's working correctly now, whenever the tower sees an enemy, he's going to shoot a lot of projectiles. So fingers crossed. Starting up, that's a good sign. Let's place our tower there and let's see what happens. And he's sure shooting, but the update is somehow wrong. He seems to only be able to shoot in one direction. I see the mistake. It's not total distance equals x distance equals y distance plus y distance. So let's try it again. And let's try placing him right there. Let's see what happens. And it's working. Perfect. But he's shooting like... So we need to fix the cooldown actually. So let's go to our tower manager, and if alive, is enemy in range? If it's true, then if tower dot is cooldown over, just returning a true, then shoot enemy, and also t dot reset cooldown down, like so. And we need to add these two values, or these methods, to our tower. And also the other one. Nope. Create method, like so. We're gonna bring those up to, say, up here. We could probably solve this by using system.currentTimeList, but in case we pause the game, then we need to figure out how to solve for that. So let's just keep a counter. It's simple, it's easy. So let's add a CD tick for a cooldown tick. So in this is cooldown over. Return, can you start from here? Return CD tick larger or equal to cooldown. If that's the case, then CD tick equals 0. But now we need a public void update, which will simply be CD tick plus plus. And in our tower manager, we go back here for our update. But we're gonna change this method right here a little bit. We're gonna take the tower loop in here and remove one of those, like so. And we're also gonna say t.update first of everything. And in here, we need to pass in the tower t. It's gonna do the exact same thing, but instead of having the update in the attack enemy if close, we now have it in the update method correctly. Let's take a look at our constant class here to check the cooldowns for each tower. It's 10, so 10 updates I think is good to begin with. We're gonna change it, of course. Everything works there. Let's go to our game again. Let's place the tower in the same spot and see what happens. Alright, it's quite fast, but it's working much better. Let's keep it at this speed for now. There's two things we need to fix. We're gonna start with the obvious one, which is the enemies don't take any damage when they're getting hit. So that one we need to fix right away. In our projectile manager, where we have our updates somewhere, and in this method, we first gonna start by if p dot is active, because they're gonna go inactive when they are destroyed or hitting an enemy. And right under the move update, we check for hitbox. So if is pro hitting enemy, projectile in there, then we get a return or not. Else we do nothing. But if it does hit the enemy, create method. And we need the enemy list, which we get from playing. So make a loop here for enemy e playing dot get enemy manager get enemies. And add some brackets. Just make sure it's imported. And what we do here is if e dot get bounds contains p dot get position. And if this is the case, they overlap, then we say enemy dot hurt. But we need a damage value, and one thing we're going to be able to do is to increase the damage done by towers. So we can't go to our constant class to find the damage there, because some towers might be upgraded and others not. So we should probably store the damage in the projectile. I think that's the best way of doing it. So let's go to our projectile, add yet another variable. So let's add a new integer. Let's keep our damage values integers. We can change it to floats later, but for simplicity, let's just keep them integers. And we need to get the damage value right off the position. So int damage. And this dot damage equals damage. Then we need a getter for this as well. Public void get damage, return damage. Now we should get some errors in our projectile manager. Right here we need the damage. But where do we get the damage for our new projectiles? Do we have it something in our towers? Yes, we have a damage in our towers, and we can get the damage from our towers. Perfect. So t.get damage. And we get an error because our damage is a float in our towers. Let's actually keep that as an integer. So let's remove that, move the damage up to becoming an integer, set default damage, that returns a integer or a float. So let's just keep it an integer. In our constant class, there's a lot of jumping back and forth, but yeah, that's what you get when you make a tiny little mistake or want to change just a tiny bit from a few episodes back. But it's still red because we return it as a float. So now it's an integer, stored as an integer, given as an integer, and returned as an integer. Yeah, so now everything works like that. All right, I think everything is changed correctly. So let's get back to our projectile manager. So if we're hitting the enemy, then we heard it, and then we say return true. So we did hit it, and we go back to here where we got the return, which is true, then p.setActive false. Let's run the game and see if we can hurt the enemies. But before we start the game and test it, we need to add one more check. It's in our draw function here for our projectiles. If p.is active, then we draw it. We don't want to draw it if it's not active. And we already have the active check here in the loop since before. So let's start it. Let's place a tower there. And let's see what happens. All right, we're not damaging the enemies at all. Well, it took me a few minutes to figure out, but there's two things here. That's the problem. First off, let's go to our is projectile hitting the enemy in our projectile manager. And here we say e.hurt projectile ID. Like, what is that? It's supposed to be p.get damage. So now we have the correct damage. But visually, it looks like that the arrows are actually hitting the enemies. Like, obviously they are. But we're checking for get bounce, not position. And the bounds in our enemy class is the hitbox, but we never update the hitbox. So go to our move right here. So every time we update the move, we update hitbox. So let's create that one. And all we want to say here is bounds.x equals x, but it's a float, so we cast that into an integer. And the same for y. Bounds.y equals int y. Like so. And now I think it's going to work. So let's try it. Put an enemy right there. And it does. It's actually working. That's cool. There's still a few things we need to figure out, but it's working. Perfect. And I'm going to end the episode here. It's been over 20 minutes and we got more work for our projectiles before they are complete. So let's save that for later. I want to thank all of you for watching, and we're close to that 200 sub number. So please, if you like this episode, smash that like button as well as subscribing. You don't want to miss the next episode. So take care now, and I hope to see you in the next update. Bye.